Hello my dear students, I am B S Pandey, your physics lecturer. Today we are in second part of lecture which was based on constraints body problem. Okay, today we will in lecture number 30, but it is the second part of constraints body problem. In standard 11th, my dear students, the question you will face in your school examination that would be not very difficult to solve, but in competition, because you will not get the another time to get practice over such type of question, you have to take all the syllabus, all the things simultaneously. Okay, so here the second part I have been given you of the lecture number 29. It is the lecture number 30 now. Of course, it is the second part of the 29 Newton laws of motion, and we are doing the questions of constraints body problem. Okay, constraints body problem part 2. All right, we have studied in part 1. I'll suggest to go and find my video on YouTube, the lecture number 29. Then you will get the concept how to solve this type of question. Directly I am taking the questions here in this second part. Okay, but let me recall you one thing, my dear students. What we have studied according to virtual work method. Virtual work method. Remember, my dear students, don't try to find this method in your book, in your standard 11 book. We have studied in graduation, but as we have studied in our graduation, I am facilitating you this method to you to solve the questions easily. Remember, this is not very tough method, so that's why I am here introducing this method. All right. And you can learn this one. According to virtual work method, what we have studied the T into X, T1 X1 equals to T2 X2. The relation 1, the first relation, we have studied T1 V1 by differentiating this with respect to time. Here the tension is constant. T1 V1 equals to T2 V2 and T1 A1 equals to T2 A2. These three things we have considered. What is meant by the T1 T2 V1 V2 and A1 A2 you will get by the problems. Okay, so let me start the today's lecture with a simple question. We will solve few questions of SC Verma and IIT problems also. And remember, all the questions are very simple, my dear students. Okay, look at here. If this is a block of certain mass, suppose M, it is connected with a string, goes over a pulley, alright, and it is given here the angle 37 degree. Okay, if this body is pulled by 10 meter per second, then you have to find, remember this is a pulley, if this body is pulled by this string with a 10 meter per second, then you have to find the horizontal velocity of this block. What will be the horizontal velocity? If you are telling the velocity remains same, it is 10 meter per second, then you are incorrect. Okay, then you have to find the velocity the block will move with the along the horizontal direction. How you will solve this question? Okay, now let me solve this question. If you are thinking, then very good. Otherwise, let me solve. This is the first question of our lecture number 30. How we will solve? My dear students, we will use this relation. What we have studied here, the TV constant, that is the T1 V1 is equals to T2 V2. You can solve. There are a number of methods that are the long method. Okay, long method. But here we are using the shortcut. Suppose it is the tension T over here. What will be the tension to the entire string? It will be the T. I hope you understand. Yes, it will be the T. Now this body we have to consider the velocity along this direction. It means we'll have to take the tension in this direction only. Okay, remember all the directions should be same. If you are considering the tension in downward direction, the acceleration should be in downward. If it is in upward, then tension should be in upward. Here we are considering the velocity in this direction. Of course, we have to take this tension in this direction only. So this tension will have the two components, one along this one and the one along this one. This tension can be written as the T sine 37 degree. Am I right? Yes. T sine 37 degree. Now we can write here the T into V. T into V, how much it is? 10 is equals to T into V. Here T is T sine 37 into V, that we have to find. Alright, so T will be cancel out, and then V is equals to, you can write here 10 by sine 37, it is 3 by 5. Alright, so V will be 50 by 3 meter per second. I hope you understand. Now, another question. Did you got this question, my dear students? Okay, try to note down this question. Now the next question, okay, this question you will find in SC Verma as well. Remember, my dear students, here we have solved this question. We have calculated the velocity at certain instant when the angle is 37 degree. Remember, as it will move forward, at each instant the angle will change. So we have calculated the instantaneous velocity. At that instant the angle is 37 degree. Yes, it should be very clear while you are solving the question. Now, this is our next question. This is the mass. Suppose m and this is 3m. Okay. Now you have to find the velocity. If the velocity of this is 5 meter per second, then what will the velocity of this block? You have to find the acceleration. How you will solve? Also, you have to find tension in each string. Here you can see this string is changed from here. This is the axle of the pulley. From here the another tension. The red color is the another string. Remember, this is not the same string is going. Alright, the another string. Now, how you will solve this question? If you can solve, try to solve this one. Okay, now pause the video and solve. Now let me solve, my dear students. What we have to do? First we have to take the tension. Suppose it is T. What will happen? Here the T, here the T. But here it will be the 2T. How? It is the tension T, T, and this will be the 2T. Now we can write here the free body diagram as mg and this is as 3 mg. Alright, now I'll solve our. Here you can write the tension, suppose it is T naught. So we are having the different. Otherwise you can find out the tension as well over here. This will be the T, T and T. So it will be the 3T. Then you can write the tension as 3T as well. Okay. Now we are going to solve this question. Here, my dear students, you may be asked the velocity of this pulley also. Remember, not the velocity of this block only, but you may be asked to find the velocity of this pulley also. Remember, the answer will be same. The pulley will move with the velocity, with the same velocity this block will move, because both are connected without any constraints. They are connected directly. So this pulley and the block will move with the same velocity. Now we are going to use that relation what we have studied. So we have studied here the T into V. Here T into V is equals to the T into V. It is how much? 2T into V that we have to find. Alright. So we have written here the v t will be cancelled out. So v is 5 by 2 meter per second. I hope you understand. Okay. Now the next we have to find the tension and acceleration. Okay. So to find the acceleration, first we have to find the relation. Suppose this body is moving down with an acceleration a1 and this body is moving up with an acceleration a2. Okay. So we are going to find here the relation. What will write? A1 into t equals to A2 into 2t. 2t will be cancelled out. So A1 equals to twice A2. We got a relation. It means if A2 is A, then A1 will be how much? 2A. If A2 is A, it is A, then A1 will be 2A. Okay. Now you are having the acceleration as well. You can write the equation. This is the t and this is the 2t. I am going to write. We have considered this is moving down with an acceleration a1. We'll put the axis positive downward. It is x and y, and we will put here the positive axis upward. Alright. So for this body we are writing who is responsible to take this block down. It is mg. So mg minus t is equals to ma. How much? It is 2a. Alright. Now this is the equation 1. For this body, which one is responsible to take the body up? It is twice t. So 2t minus the force, it is thrice mg, is equals to ma. It is thrice m, and the acceleration it is a2, which is a. Equation 2. Now we are going to solve this one to find the acceleration a. Here, my dear friends, you can see if you multiply it by 2, you can solve this equation. This 2t will be cancelled out. You multiplied by 2. 2t will be cancelled out, and then you will have the twice mg minus thrice mg is equals to 437. Sorry. 7 ma. M will be cancelled out. So a is equals to minus g. A is equals to minus z. Now you can see we have considered this block is moving down, but actually this block is not moving down. Actually this is moving up. Alright, and this is moving down. Yes. Now we are having the equations for tension. We have calculated already the acceleration. It is 10 meter per second square. Now we will put the value in this equation to find the tension. Okay. Here you will put the value of A. You will get the tension, and in this way you will have the answer. Okay. Now my dear students, if you understand this one, try to solve another question. Let me draw this one. Okay, one more question. Let me draw first. Then I'll draw. Here in this pole, a ring is adjusted with the string, and this string goes over a pulley. Alright, this string goes over a pulley. Now this string is to be stretched, pulled down. This string has certain mass. Alright, if it moves with 5 meters per second down, then you have to find the velocity of this ring. What will be the velocity? Alright, and you have to find the velocity of this ring when this angle is 37 degree. Yes, at that instant you have to find the speed of this ring. It will move up. With which speed it is moving. when it reached to the point at 37 degree, you have to find the speed of this ring. I hope this is very simple for you, my dear students. Let the mass of the ring, whatever may be, it will not affect the velocity, because here you have been given the constant velocity. So you have to find the velocity of ring with which it moves up in the pole. If you can solve, try to solve this question. I hope you can solve this question, my dear student. This is not very tough. Use the same concept, virtual work method, that is TV constant. Okay, now let me solve. Suppose here the tension is T, then tension will be T over here also. Okay, but we have to find the velocity in this direction. It means we have to take the component of this velocity along this one. And if it is the T, then the component of tension will be T cos 37. Am I right? Yes. Now, you can write here the T into V. Let me write over here also. The T into V is equals to T into V is equals to T cos 37 into V, that we have to find. T will be cancelled out. So V is 5 by cos 37, it is 4 by 5. That is V equals to 24 over 4 meter per second. Alright, yes, this was the answer. Okay, now try to solve one more question. Here one question I'm giving you for you as a homework. You have to find the relation. This is the m, this is the 2m. If its velocity v1 and its velocity v2, then you have to find the relation between v1 and v2, my dear students. Okay, this is the question. M, you can say it is 10 kg. This is the very important question. It will open some concepts. Remember, this question comprises with concepts. You will compelled to think over this question, how this answer is coming. Okay, and then I will ask you that what you got the conclusion from this question, and try to solve this question here. You have to find the relation between this velocity, okay, and acceleration of the system. You have to find relation between velocities v1 and v2. The second thing, you have to find acceleration. Third, tension in each string. Tension in each string you can write here. Alright. You have to find all the three things. Okay. Now, my dear students, I'm going to solve here another question. Remember, this is your homework. Now, I'm going to solve here another question. It is from S.C. Verma. This string, it is attached with a block. A pulley is attached with a block. Let me drop this one. I hope you have noted down this homework. I don't have sufficient space, that's why I have to rub this one. Yes. Now, and it is connected with a block. All right. Suppose the values are given, it is twice m, or you can say it is the thrice m. In SC Verma, this question is given. What you have to find? You have to find the relation between V1 and V2. Suppose it is V1 and it is V2, then relation. You have to find tension and acceleration of each block. Okay? Okay. So, let me solve this question. Here, the tension we will use to represent, suppose it is T. Okay, so this will be the T, this will be the T, and this will be the tension 2T. Am I right? Yes, it is 2T. Now, we can write here that TV2 is equals to 2T, suppose the V1. So 2T V1, the T will be cancelled out. Then V2 equals to 2 V1. This is the one relation. Now for the acceleration, we can write here, suppose if this is moving down with an acceleration A1, then it will move with an acceleration A2. Okay, so we are going to write here the relation between A1 and A2. It is T into A1 is equals to 2T into A2. So this is cancel out, and A1 equals to twice A2. So if this A2 is A2 is A, then it will move with an acceleration how much? 2A. Okay. Now start solving this question. You have to find acceleration, you have to find tension in each string. So here this body is moving down thrice mg. Okay, so 3 mg minus t is equals to 3m, and the acceleration A will be acceleration, it is A1, and we have written here the A1 equals to 2A. This is the first equation. For this one we can write here that 2T is responsible to move this body because no force it is acting to stop this block or against the motion of against the 2T. So it is twice T equals to m times A2. It is A. This is the equation number 2. Alright. So we can write here the T is equals to MA by 2. Then this will be cancelled out, and we will have 3 mg is equals to, it is 6, 12 and 13 ma by 2. Alright. So m will be cancelled out. A is equals to 6g over 13. Once you got the acceleration, my dear friends, if A is 6g by 13, it is 60 by 13 meter per second square. It means the acceleration of A, we have written here the acceleration of this one as the 60 by 13. So the acceleration of this block will be twice the 60 by 13. Okay. Once you will put the value of A in this equation, you will get the tension as well. And then you can find out the tension. If you will ask to find the net force on this ceiling, what will be the answer, my dear students? Look at here. If you are asked to find the net force on this ceiling, so you can see here the tension T and here the tension is T. Okay, so the net force, it will be not the 2T. The net force will be here, you can say, over the resultant force Fr. The two forces are acting at 90 degree. So Fr will be root under T square plus T square. Okay, so T root 2. You got the value of T from equation, then √2 times T will be the force on the ceiling, that is the applied by this pulley. In this way you have to solve the questions. Okay, now one more question that we discuss. Let me write this one. Now one question I'm going to give you to find the velocity, and this question was asked in competition. I have taken this question from competition corner. Okay, yes, and this is the question. This is the pulley, another pulley, a block, it is tight here. The two strings are pulled simultaneously with velocity u. Okay, then what will be the velocity of this block? The mass you can take, and this is the values as given here. This is the theta angle. Okay, it is theta. You have to find the velocity of this block. How you will solve this question? If you can solve, try to think, my dear student. Yes, this is not very difficult. Pause the video and try to solve this question. Okay, now let me solve this question. Here we can write here the tension T. Since angle are same, here the mass and the pull with the same velocity, so the same tension we can consider the T and T. So it will have the two component of the tension. My dear students, since the velocity we are considering in upward direction, so the tension component we will study in upward direction, T cos theta and T cos theta. All together we can write the 2T cos theta. So we'll use the concept of virtual work method. The total work given by these two forces will be equals to the work done by this forces, that is this forces. So it is the T, of course this is the tension T, and here also the tension T. So the TU plus this TU, it is equals to 2T cos theta into V. Now you got the answer. It is T will be cancelled out. So V, it is 2 will be cancelled out here, the 2U by 2 cos theta, it is U by cos theta. Answer. Okay, so this is the answer, and I hope that you are able to understand. Now let me conclude today's lecture, my dear students. I am giving you one homework. This was the second part of the lecture 29. I thought to solve few more questions for a clear concept of this constraints body problem. We'll solve few more questions of constraints body problem. I will give you here one more question. I'm giving you as a homework. But the previous homework, what I have given you, the last question in homework in today's lecture, that was very important, and I hope that you must solve that question. Okay, my dear students, so write down the next homework. It is not very difficult, this one also. On inclined plane, a block is kept, angle it is 53 degree. This is the pulley. Okay, here the another pulley. And this pulley is tightened with some hinge over here, and another pulley it is hanged over here. This is M, and this is 2M. You have to find, it is a 3M suppose, you have to find the relation. If it is V1 and it is V2, then find the relation between V1 and V2. And also you have to find, what you have to find here, the first relation between V1 and V2. The second, you have to find tension in each. And the third, you have to find acceleration of each. Okay, this is your homework. Okay, my dear student, so we have finished here the second part of the constant body problem. In next class, we will solve the question which are based on pseudo force, and we will study inertial and non-inertial frame of references. Okay, my dear students, so this is all about today's lecture. Thank you very much.